Hello there and welcome to the new Power BI weekly challenge or the workout Wednesday that I am picking up, where you have the Power BI challenges. And this week, or at least for me, I'm not following like week on week, but whenever I find time, I attempt the exercise and then create the video for you so that you get crisp and concise details. And then wherever possible, I add some of my inputs to it, so that along with this, if anything which I feel from my experience, I'll try to add that. So this week I am taking up the week 9, and here is the week 9. So week 9 is all about forecasting and anomaly detection. So forecasting is comparatively very easy if the data is in a proper structure, like you have dates or a time series data, and you want to plot it, let's say sales over time, revenue over time, or headcount over time, things like those. Then you can very easily enable the forecasting like it has been shown over here, right, which can give you the directionally right figure. Obviously it is forecasting, it will not be ever 100% accurate, but some directional as to where this is going. And then you have to or companies, or when you work with the environmental data like this greatly, you always want to find out where is the maximum ups and downs, like anomalies, which is outside the range of average or the confidence area. Like in this case, within anomaly detection, we are using the sensitivity of around 75% that you will see in the instructions. So this is something which is based on week 5, or I don't know, week 7 challenge. This challenge will look similar to Power BI week 7 challenge, yes, because Great Lakes data was used at that time. So here you have week 7. Yeah, so this is where we have looked at each and every lake and their respective I think temperatures, if I'm not wrong. That's what it is. So if I go to this, you have values, but this is all about temperature. Yeah, so we are building up upon that. So if you have not followed it, still not an issue. You can get the data model by clicking it over here. The links and everything is present here in the description for this exercise. Also, a quick information about all the videos that I'm keeping in the one single repository, like a live Google Sheet. So this sheet link is also present in the description, where I have my 200 videos listed in the tab Feature Explainer. The only thing is, you will be able to easily come here, search any of the video, and using the link present in the column B, you can jump to that video directly. So just so that you have a better experience searching my videos. And then you have the exercises link as well. So all of these exercises which I am picking up, like till the week 8, again the video link is present and the exercise link is again present over here. So that way proper document will help me as well as you whenever I or you need a specific video. Let's say I want to revisit some of my video, or you are searching any of the video, then you will be able to find it. Okay, coming back to this, so what I'll do is go to the Great Lakes. So here you have the requirement. First thing is doing the transformation of the data. We have already done in the week 7. Now the second is the add a line chart that displays the average coverage by year forecasted out to the year 2030. Okay, so line chart. All right, here is your line chart. Okay, and I will just expand that little bit. Yeah, keeping in mind like how it has been gone, how it is present over there. And then we have the values, and we have the year date. Now this year date, what you are seeing is a transformation of year. So what I have done before this exercise, because I was attempting it before creating a video, I have this year, right, and then I use the function, the date function, as you can see, to convert this into a proper date. Otherwise the forecasting will not work. It needs a proper time series data. So you have the date, you have the great historical ice coverage year. We have to specify the year, the month, and a day. So if you see, year is basically this field, then one default first month and first date I have taken. Because it is an yearly data, it will always take like a for a different lakes like Superior 1973, Michigan 1973, and similarly again for 97.4 you have a separate set 75, 76. So keeping in mind, like, you can do like this or any other date that you feel like is good for you, but 1st January I think is okay, because what we need is just, proper year information out of it. All right, so we have this, and then what I can do is I can add the year to it. So now you see the year is added over here, okay, and we need to enable the forecasting. So for forecasting we need to come over here, analytics pane, and then we have something called as forecast. So if I enable the forecast, that's all you need to do, but you can still go in and you have options like units is point, years, days. So right now it is in points, so that's also okay. You have forecasted length like 10, so going all the way from 2020 to 2030, okay, so showing like how the trend will be, and in 2030 the forecast is 275 compared to 2020, which is 98, right? So that is something what forecast is showing. Then forecast length you can increase or decrease, like how much you want to increase or how much you want to decrease. And then ignore the last, in case if you want to ignore the last value. Seasonality, again some settings which is specific to the forecast point you can add. Also confidence interval is this gray area, so you have 99% confidence. I think it will grow up, so I need to click on apply. And you have something called as 75. So someone who knows the statistics will know about that very well. So I'll keep it default, right? So this forecast, you have even the forecast line, like what is the forecast line you want to show, in case you want to show the forecast line. And so this is what the forecast line is, black, but let's say if you want to show in a different color, for example maybe this one, then this is what it will come, okay. So I'll keep it black. All right, and then you have confidence band. You have some styles like fill or line or none, yeah, something you can experiment with. So just wanted to show you some of the properties that you will find it related to the forecast. Okay, so once you have this, if you go back, this is, if I just expand this, come on, yeah. So this is what our forecast is, but what we need to also add an average or a sort of a trend line. So add a line chart that shows average coverage by year forecasted out to year 2030. This is done. Add a second line chart. So before adding a second line chart, I'll just add the trend line, because that is something we have not added, and as simple as that. It's the same pane, add the trend line, and you are done. You have some formatting which you can explore. All right, so we have this first chart. I can do is copy and paste. So if I just copy and paste, second chart is created, which is anomalies in average coverage by year. So average coverage by year is still the same, but we need to enable the anomalies. So I'll just reduce this, right? You now have proper line with you, like what is a line, and but now we need to enable the anomalies. And if you see the anomalies, it is right presented over here. So if you enable that, the anomalies are enabled for you, as you can see, which is similar to this chart. And then down there you have forecast out to year, 75% sensitivity. So sensitivity option is present here, which you can increase 75, click apply, and you will find the sensitivity over here, and these are the point which is outside of band is highlighted as anomalies, right? So those again who are statistics students will be able to understand, or those who understand about sensitivity and all will be able to understand what does this mean. Formatting is totally up to you. We have been loving the way the creativity, and that's the best part, like how you can be as creative as much. Answer the following question: what is the projected ice coverage in 2030 and all. So one thing which I recollected is, let me just select, we have value, we have to take the average. Same is the case over here, we have to take the average. Nothing much will change, but it's just about what is being asked. Now the last thing is, you have this lake minimum coverage and maximum coverage table. So what I'll choose is basically a table. We have lakes, we have value. Now from here we need to come to this and say minimum, got minimum of value or minimum coverage. Again bring in this and say maximum, you got maximum value, right? And then move it to this alignment. But come on, okay. All right, so you have these lakes, for example Erie 5.400, you have Erie 5.400, so our value is correct. I will probably bring this up. Also the best part is that I can select and you will see the visualization will change. By default the interaction is enabled. Okay, so this is done. The next thing is some analytical point. Now this is up to an individual or analyst to analyst, like they want to view it holistically or go point by point. My recommendation is either you go in depth into the data and cover the lowest point to the highest point and so on and so forth, or you have a way to add the smart narrative, creating your narrative, not just one point but many points, right? So this you can add in your visualization, bring it down, and that I feel is like way much more. It is automatically generated, again picking up mostly the same thing, but the whole thing is average of value. We need to just make sure that it is properly named and all. Otherwise average of, we can change this to a maximum coverage, like you can rename this. Come here, I think there should be a name to rename the measure. Yeah, rename. So you can rename this so that instead of average of value it should say probably average of coverage. Okay, so not just one, but this is what my recommendation is, to add it. Again, as an analyst, because I'm not going very much into in-depth the data, my whole point is to show you the analysis or how you will create it. But if you go down, if something does not make sense, for example, if this does not make sense, just select this and delete it. It's as simple as that. And this changes based on what we are changing. If you see, this is changing. So that's what mainly I wanted to show you, how you can do that. Again, last thing is formatting. I leave it again up to you. The whole thing is you can use the text box to create something like Great Lakes Ice Coverage. Use the formatting present here and here for the font, and the font color is present here. You can come over here in properties, the effects. You can change the background and all, right? So something very, very specific to what we want to do. Leaving it up to you, how do you want to do that? One last thing also I will show you related to the formatting is how you will have this background, right? So for that, what you can do is you can come over here and insert shape, take the shape, right, this shape, and move it to the back. The way you will do it to the back is going into the view, selection, right, and move shape in the end, and you have the shape, right? The only thing is you need to format the shape. shape, style, color, maybe this. Okay, so that way your shape is coming. Do the same for this, make the alignment, and your report will be ready. So like within 15 minutes we have the report ready, and that's mainly what I wanted to show. Second, one last thing before going is this: what is the projected ice coverage in 2030? Is your 55.07. Which lake contributed the most to anomalies? So you need to select. You have close to 1, 2, 3, 4, 5, 6, 7, 8 point, less point, 3 point, even 4 point, 1 point, 3 point. So Erie Lake is basically contributing to the most, and that's your answer. So thank you so much for being with me on this exercise. I will meet you in the new exercise maybe next time whenever I'm ready.